Welcome to our Exploring Science training. My name is Jennifer Elligood, National Training Manager for National Geographic Learning, and I'll be your presenter for this session. Exploring Science is an elementary science program developed specifically to cover 100% of the next generation science standards. As you'll see today, it combines instruction in science and engineering practices, disciplinary core ideas, and cross-cutting concepts to meet the rigor of the next generation science standards. Throughout this session, I will walk you through the program components and provide you with an overview of the instructor-led path, which includes introducing using the science notebooks, the design of the program lessons, and our assessment resources. We'll also reference the interactive eBook. Let's first take a look at some of the key benefits of exploring science. Exploring Science will support you in teaching the next generation science standards with confidence and will ensure that your students are mastering 21st century science skills by meeting 100% of these standards. This program introduces real-world science research with National Geographic explorers, scientists, and photographers. And we connect next generation science standards content with investigations, engineering practices, and case studies for complete immersion. Let's look at the student and teacher resources you'll have access to. Kindergarten is comprised of 3 big books, one for each strand: life, earth, and physical science. Grades 1 through 5 have 1 student book, each of which includes 100% mastery of the next generation science standards. Student books are available in English and Spanish, and in print as Vital Source ebooks, and also as an interactive ebook through our myngconnect.com platform, while teacher's guides are available for each grade level for complete support of the next generation science standards. Take a moment to pause the session and look through your student book. See if you can identify areas where students will be engaged and where the next generation science standards are identified. Do you see STEM content? And what about hands-on opportunities? When you've finished exploring, hit play to continue our session. When thinking about engagement, who better to engage our students than National Geographic? As I mentioned before, there are 3 strands: physical science, life science, earth science. There are also space sciences, engineering, technology, and applications of science that are all introduced and presented to students utilizing stunning National Geographic photographs and images. Our expert authors and our exclusive access to National Geographic explorers bring real-world science practices directly to students. They inspire students to consider current, topical, real-world problems. They give the message to students that science is exciting, engaging, and an overall benefit to helping others. And the science career lessons inspire students to become scientists and explorers. When it comes to standards coverage, you'll notice that not only are the next generation science standards covered in the teacher's guide, but they're also covered in the student book, as you can see here in the lower left-hand corner. If you're in a state that has adopted these standards, you already know how important it is that students have access to the standards that are being covered. The Science Career sections use National Geographic Explorers to provide students awareness of STEM, science, technology, engineering, and math, fields, and occupations, and also motivate them by revealing aspects of science they may never have thought of before. Explorers provide exciting, current, real-world examples of an integration of disciplines without the traditional barriers between science, technology, engineering, and math, focusing on innovation, addressing questions, and designing solutions to complex problems. The Think Like an Engineer sections use case studies and National Geographic explorers to engage students in real-world problems and designing solutions to them. Case studies provide a basis for introducing current, real-world problems. Explorers then guide students in engineering design to help solve these problems, in this case, designing an effective solar oven to cook without utilizing resources such as wood, gas, or electricity. Hands-on investigations are embedded throughout the student book. You can see that the materials required for these activities are simple and easy to find, and you'll usually already have them in your classroom. These investigations allow students to meet the performance expectations. Here is the performance expectation from the bottom of the page, where students are asked to develop a model of waves to describe patterns in terms of amplitude and wavelength, and that waves can cause other objects to move. Exploring Science provides the core ideas and the hands-on investigations to support students in completing the performance expectation. Now let's take a look at the instructional path. I'll be using grade 4 as an example, but the path is the same at each grade level. When you begin using Exploring Science, the first thing you'll need to do is work with your students to set up their science notebooks. Once you've done that, you'll move into the Strand instruction, whether it be Earth, Life, or Physical, with the Strand introduction. Within that strand, each lesson will implement the 5E instructional model. Then you'll move through the disciplinary core ideas and the performance expectations. Finally, each strand and each lesson ends with some form of assessment. Take a moment to read this quote. You'll notice how we don't use practice books with Exploring Science, but instead choose to model real-world science experiences and investigations. Science notebooks are an integral part of the Exploring Science program. Writing in a science notebook improves student understanding of science content and process. Using a science notebook also improves reading comprehension scores on state standardized tests. And science notebooks also give students an opportunity to record observational data and develop inquiry skills while serving as a context for developing literacy. And finally, real scientists record their observations and share their data with colleagues. There are many parts that make up a science notebook. Please pause the session again to read the Science Notebook handout packet, which covers helping students to set up their science notebook, learning what's in a science notebook, finding out how to use a science notebook for inquiry activities, and finally you'll be experiencing how students will incorporate science academic vocabulary into their notebooks. Setting up the science notebook is a critical stage of the process. As you learned by reading the handout packet, you should allow students to choose their organizational style, notebook, decorate the cover, create a table of contents, and number the pages as they go so that they have ownership over their notebooks. Here we'll take a look at a few real examples of science notebooks from a second grade classroom. You'll notice that this teacher used spiral notebooks and index cards to separate sections for each unit, while this teacher used a 3-ring binder, which makes it easy to insert pages when necessary, and she even used plastic sheet protectors to store some of the student work. A composition book is another option, and you can see the little pink tab that's used to divide the units. Also notice how this teacher combined the learning masters by gluing or taping them into the book and the original student work. And this teacher taped a Ziploc baggie to the inside of her notebooks for students to store their vocabulary words. There are 4 key elements you'll want to have students recording in their science notebooks. The first is their notes and thoughts about the big ideas. In these examples, you can see the students took notes related to the big idea questions and some of the information they already learned. The next key element is the new vocabulary that students are learning. As you can see, students can also use their science notebook as their own vocabulary resource. In these examples, you'll notice there are different ways students can record this new vocabulary in their science notebooks by writing out the words and definitions, or even through artistic representations. Students should be encouraged to jot down content notes from each lesson in their science notebook. They can even include graphic organizers, charts, lists, questions, and sketches. At the end of each lesson, they can go back and use their science notebook as a resource to review what they've learned. And the fourth element are the inquiry observations. These are observations and notes students take during their activities. These examples show students' written observations. Remember to model how students can begin to think and write using their science notebooks. As a teacher, you should have your very own science notebook that you can use as a model. Now that we've seen how to set up the science notebook, we'll take a look at how the strands are introduced. There are 3 strands, as I mentioned, within Exploring Science. Each strand, physical science, life science, and earth science, is introduced and presented to students at point of use, utilizing related photographs and images. When we introduce a strand to students, it will always be a 2-page spread. Here's what the physical science strand looks like in the student book. Although the page looks very basic in appearance, when we turn to the teacher's guide, we see that there's a lot of instruction happening behind the scenes. The introduction of the strand within the teacher's guide allows you to see exactly what students should be able to demonstrate by the time they've finished learning about, in this case, the physical science strand. Each strand is introduced in the teacher's guide as it occurs within the student book. Here you can see that the strand being introduced is physical science. This layout is consistent throughout the program for all 3 strands. And this is also the point where the next generation science standards performance expectations are introduced within the teacher's guide. You'll also notice that above the initial performance expectation that each strand is broken down into different elements. Here the element of the strand is energy. This is also where the disciplinary core ideas, the science and engineering practices, and the cross-cutting concepts are located. Now we're introduced to the next element after energy, which is waves. You can also find the performance expectation and the disciplinary core ideas listed, as well as the science and engineering practices and cross-cutting concepts in this section as well. On the next page after waves, you'll find engineering design, and again you'll have the performance expectation, the disciplinary core idea, the science and engineering practices, and the cross-cutting concepts listed. Now that we've seen where the strands are introduced, we'll take a closer look at the lesson design of Exploring Science. In the student book, each lesson is designed to be taught on 2 pages, meaning each 2-page spread equals 1 lesson. Students will always see a header in the upper left-hand corner. Here our header is Batter Up, that introduces the main topic or focus of the page. Visuals are built in to help support student understanding of the concept, and at the end of each lesson you'll have the Wrap It Up section that you see in the lower right-hand corner where students will engage with the science notebooks we just discussed. Meaning students would answer the question within their science notebook. Now let's take a look at the same lesson from the teacher perspective. Just like the student book, each lesson in the teacher's guide is also a 2-page spread. Each lesson begins with the disciplinary core idea and the performance expectation listed. Beneath that, you will find the objectives for that lesson. The 5E model of inquiry instruction, engage, explore, explain, elaborate, and evaluate, is used throughout Exploring Science to allow students to use and build on prior knowledge, to construct meaning, and to continually assess their understanding. Even at the kindergarten level, students engage in each of the levels of the inquiry process. First, we engage students by tapping their prior knowledge. Then we explore by previewing the lesson and setting a purpose before students begin reading. Next, we explain by defining, explaining, and making connections for students. We elaborate by extending what students have learned about the topic. And we evaluate students by using the Wrap It Up student notebook activity. And finally, each lesson contains resources for teaching with technology. technology, the connection to the Common Core state standards, support for English language learners, science background for those students who need additional background in the content before they begin the lesson, explanation of science misconceptions, as well as extra support for students, and a challenge for students who are accelerated learners. Now let's look back at the student book for a moment. In the lower left-hand corner of the page, you can see the disciplinary core ideas that are introduced to help students meet the performance expectations. Exploring science always starts with the performance expectations in mind. What do kids have to be able to do at the end of the learning? Then we figure out how to prepare students with our materials so we're 100% convinced that they can achieve the performance expectation. The next generation science standards are all about the doing of science. The investigations embedded throughout Exploring Science allow students to do just that. These investigations are targeted to apply students' knowledge of the Strand so that students are able to connect the disciplinary core ideas to both the content and activities that they are completing. At the bottom of each page, you can see that the Next Generation Science Standard performance expectation is visible at point of use for students. Also shown on this two-page spread is the Wrap It Up section, which supports classroom discussion on the topic, as well as a student science notebook opportunity to reinforce what students have learned. This is what the lesson design looks like in the teacher's guide for the investigation. As you can see here, the performance expectation is listed at the top of the page, and right beneath that is the objective of the investigation, so that students can understand how this ties back to what they've learned. And even the investigations in Exploring Science follow the 5E model that we discussed: engage, explore, explain, elaborate, and evaluate. The built-in classroom management suggestions for these hands-on investigations helps to factor in the total time spent, any advanced preparation for the teacher, tips to the teacher, and what results the students can expect. Take a moment to pause the recording to explore the student book and find lessons that are different than the ones we just looked at. For example, any lessons that are new, different, have a different structure, idea, and so on. When you've finished looking, hit play to resume. So what did you find? You should have noticed how students have the opportunity to think like an engineer through case studies and designing, testing, and refining a device, or how they're called upon to think like a scientist, exposed to new and different careers in science, and conduct quick science experiments using science in a snap. Now let's look a little closer at each of these sections. You may have already noticed that the student book follows the same instructional pattern until you get to the case studies section of the Strand. This is found on page 32 of the Grade 4 Teacher's Guide and page 32 of the Grade 4 Student Book. This case study asks students to think like an engineer by first presenting a problem. This is one more way in which we provide deep coverage of the standards within Exploring Science. We incorporate case studies so that students have the opportunity to think and act like scientists and engineers. With the addition of the Next Generation Science Standards, knowing and doing cannot be separated if our goal is the kind of usable, conceptual understanding students need to think, act, and learn like scientists. Once they've learned about the problem, they are then provided a solution to that problem. Again, this is a key feature of Exploring Science and one of our many differentiators. We provide real scientists doing real science that integrates technology and principles of engineering design, so that students then have a model to follow when they conduct a similar task on their own. And now it's the students' turn to activate their learning through designing, testing, and refining a device. This is where students will have the opportunity to find a solution and test that solution. This is also an assessment measure because students must have a good handle over everything that was taught before this in order to solve these problems. First, they must define the problem. Second, they need to find their own solution to the problem. You'll notice that this can be trapped within the science notebook, which is indicated by the red science notebook icon you see here. Then, students have the opportunity to test their solution. They can then refine or change it, compare their data, analyze and explain their results, and finally present their results. We know that scientific ideas are best learned when students are able to engage themselves in practice. In this activity, students are again able to design, test, and refine a device. You'll notice the My Science Notebook icon, which indicates they'll be using their science notebooks for this activity. Notice how the important aspects of the scientific endeavor so often overlooked in science education are included here: analyzing and interpreting data, constructing explanations, using evidence, obtaining, evaluating, and communicating information. We also have a Think Like a Scientist section to help students develop real-life science skills from the next generation science standards, such as developing models, making observations, obtaining information, planning investigations, and making an argument. The Science Career lesson allows teachers to expose students to various careers in the field of science. These science career lessons introduce students to a variety of National Geographic explorers and scientists that are currently conducting cutting-edge research in the field of science. This exposure can help to provide students with an interest in a future career in science. A variety of investigations support disciplinary core ideas and performance expectations in exploring science. Both the investigations and the Science in a Snap offer opportunities for hands-on experiences to reinforce science concepts. Science in a Snap is a hands-on way to introduce a topic that's either more complex or more conceptual and is aided by a quick visual activity. Now that we've finished looking at how the lessons are laid out for students and teachers in exploring science, let's turn our attention over to assessment. The first level of assessment can be found in the wrapped up questions on every page of the student edition where a core idea is presented. Each lesson in the teacher's guide includes an Evaluate section that includes questions, and students then record their observations and answer these questions within their student notebooks. The Evaluate section also reviews the wrap-it-up questions for core ideas as well as provides rubrics for assessing student performance where performance expectations of the next generation science standards are addressed. There is also a disciplinary core idea review section in the back of the teacher's guide. This can be used to test students on their knowledge of what they've learned. Here on page 170 of the Grade 4 Teacher's Guide, you can see sample review questions. There's also an answer key for the disciplinary core idea review questions located in the back of the Teacher's Guide. The interactive ebook located on myngconnect.com also has additional opportunities for assessment, including vocabulary games and the interactive science notebook sections. For more information on the Exploring Science interactive ebook, please view the interactive ebook on-demand training module. Congratulations! You've completed the first on-demand training module for Exploring Science. This session provided an overview of Exploring Science and all of the program components. I also shared the instructional path, including how to set up your students' science notebooks, what the lesson design looks like, and what assessment resources accompany the program. Thank you for joining our session today. Please take a moment to complete the survey provided by either clicking on the link or on the QR code.